Okay, problem number 10. The displacement s meters of a car t seconds after leaving a fixed point A is given by s equals 10t minus 0.5t squared. Calculate the velocity when t equals 0. Okay, well, in order to do the velocity of t is equal to the derivative of s. So we need to figure out the derivative of s. So the derivative of s is going to be 10 minus 2 times 1/2 is 1. So that would be 1t. So that's my derivative. So now I want to figure out the velocity. So the velocity of when times 0, when t is 0, is equal to 10 minus 1 times t, which is 0. So the velocity at time 0 is equal to 10. So that would be answer A. Answer A would be 10 meters per second. Calculate the value of t when the velocity is 0, right? So I'm going to take my velocity function and set it equal to 0. So this is part B. 0 is equal to 10 minus t. I'm going to add t to both sides, so I get t is equal to 10. So answer to B, calculate the value of t. T is equal to 10 seconds. Okay, next question. Calculate the displacement of the car from A when the velocity is 0. Calculate the displacement of the car when the velocity is 0. So at time 10 seconds. Okay, so there's a couple ways I could do this. I am going to do the, it says the displacement is equal to this. So I'm going to go ahead and just plug in 10. And then I'll do it with an integral. Okay, so since I have the displacement function, I'm going to say, okay, where is it? What is the displacement at time t is 10? Minus 0.5 times 10 squared. So we get 100 minus 0.5 times 100. Half of 100 is 50. So it would be 50 meters. So 50 meters. Okay, so I could have done this just to try it. What the heck, let's just try it. I should also be able to do the integral of the velocity function. So 10 minus t dt from 0 to 10. So it's kind of weird the way that it says, calculate the displacement of the car from A when the velocity is 0. Oh, because you leave a fixed point A. Okay, so yeah, no, I'm okay with it now. All right, so this is going to be 10t minus t squared times 1/2. And I'm going to integrate it from 0 to 10. So notice this is the same as this. So when I put in my 10, I'm going to get 10 times 10 minus 1/2, 10 squared, minus, same thing with the 0, 10 times 0 minus 1/2, running out of room, times 0 squared. Okay, this is all just going to equal 0, and this is going to give me the same answer as that. So I could have done it, here's part C again, oh, I already wrote that. I could have done part C with an integral, but since I already had the displacement function, I was able to just evaluate the displacement function. Because notice it asked for displacement, it did not ask for total distance. All right, that's that.